Let's now work with LCM and HCF using prime factorization. This is effectively the ladder method. The ladder method is a simple procedure we use to determine the prime factorization of a number. Now, let's first understand one thing. In order to use the ladder method, you need to know your first few prime numbers. Your first prime number is the number 2. Then we have the number 3. Then we have the number 5, 7, 11. Now, in order to do the ladder method, we'll start off simply by drawing a ladder of that sort. Let's just make this a little neater. Now, the first number we have to work with is 25. So you would just put 25 on your ladder. Looking at your prime numbers, you will now decide, can the first number 2, can 25 be divided by the number 2 without a remainder? 25 is an odd number, and so it will not be divisible by 2. So if you have to think of it, 25 divided by 2, it won't work. So we're gonna scratch out the 2. We can't use 2. We have to move on to the next prime number. The next prime number is 3. Can 25 be divided by 3? And you'll see the answer will also be no. So we're not going to use 3 either. What about the next prime number, 5? 25 can be divided by the number 5. What is 25 divided by 5? Yes, the answer will be 5. We write it on the next line as shown. Once we've done that, whatever the prime number is here, we will first try to use it again, which is 5. And 5 is divisible by 5, where your answer is now 1. As soon as we see a 1, we close off our ladder and we know we are done. The prime factorization of this number 25 is now going to be made up of this column of numbers that you used to divide it by. So in this case, it is 5 times 5. It is as simple as that. Let's now go ahead and do the prime factorization of 30. So it's going to be a little different because of this number, but the process remains the same. Your prime numbers need to be written down. Alright, now we'll start with our first prime number. Once again, the number 2. 30 is divisible by 2. 30 can be divided by 2, and your answer is 15. We're going to use the same prime number again. 2 does not go into 15. 15 is not divisible by 2, so we'll get rid of it. We can't use it anymore. Let's try the number 3. 15 is divisible by 3. 15 divided by 3 is going to be 5. Awesome. So we're going to try the number 3 again. Drop it down. 5 cannot be divided by 3, so we're not going to be able to use that. And we're going to scratch that out. The next number is now 5. And 5 divided by 5 is 1, which completes our ladder. And again, the prime factorization is simply made up of the numbers that we use to divide and get that one. So 30 is equal to 2 times 3 times 5. Our prime factorization is complete. We now need to find the LCM and the HCF. The first thing you want to do is create a separate space and start writing down the prime factorization of these two numbers. But I'm going to teach you something a little interesting to think about and make it easier for you to work this out. So let's write down our number first. We're going to be drawing a table. The number is going to fit in that column. And then we're going to check. The lowest prime factor we've used happens to be 2. What is the most amount of 2's we've used in any of these numbers? Yes, we only used 1 2 in 30, so we're gonna have to have 1 2 column. The next prime factor we've used is gonna be 3. What is the most amount of 3's we've used in any of these numbers? We've only used 1 3, and that's in 30, so we'll have 1 3 column. Let's go again. The next prime number we've used is 5. What is the most amount of 5's we've used in one of these numbers? It's 2. It is not 3, because in one number only we used a maximum of 2 5's, not more than 2 5's. We don't really care if it's in another number. We just want to know where it occurs the most and how many times is the most. So we'll need 2 5 columns. Alright, let's just rule that off there, create our column space, and do our numbers. Now the first number is 25 and the second number is 30. We will now refer to that prime factorization to complete this table. 25 is made up of 5 times 5, 5 times 5, and so it can only fit in the 5 column. So 5 times 5. Let's have a look at 30. 30 has 2 times 3 times 5. So 30 will take up a space in the 2 column, in the 3 column, and one of the 5 columns. These other columns will just be left blank. There's no need to put anything into them. Now, to not mix this up, this is how you find your HCF. Your HCF is simply equal to the total of your completed columns. So let's understand what that means. We have a column over here. Is this column completed? No, there's a blank here. This column is incomplete. How about this one? Incomplete. What about this one? This column is completed. Let's make a note of this. What about this last column? Incomplete. This is blank here. So HCF is simply, for this one, it's simply going to be 5. Your HCF of 25 and 30 is 5. And that is sorted out. So it's just going to be 5. What about your LCM? Your LCM is going to be made up of every single column in your table. So it's going to be made up with the 2, the 3, the 5, another 5. However many columns you've got, it's going to comprise of all of them. So 2 times 3 times 5 times 5. And you have to work out that answer to write down your LCM. So in this case, it's 5 times 5, which is 25, times 3, which is going to be 75, times 2, which is 150. So your HCF is 5 and your LCM is 150.